Yeah, is my screen is visible to everyone?
Yes, sir, it's visible.
So today we are discuss about phases of compilation, different phases. So what will today agenda will be? We will talk about TLF, types of ELF, compilation phase, and different phases in compilation, including pre-processing, compilation, assembling, and linking. We should know these things before running our C code, because until and unless we don't know the flow, it will be very difficult for us to examine the errors and different terminology. My voice is audible.
Yes, sir, you are audible.
So this all thing about me. You can I will share the PPT so you can know about me. Now let's start with ELF. In previous class, we have a little bit discussion on the ELF, and I think you people are aware about it. So who people know? Can you tell me what you have understood about ELF till now? What is ELF?
No idea, sir.
In previous class, I have discussed about TLF, but have you people have not revised the previous class?
Sir, I have some little bit confusion about ELF.
Yeah, please ask.
Sir, as we know that, sir, ELF is a type of humanoid super array.
What happened?
Sir, I don't think that you have covered this topic.
ELF have not covered. No, but I
Yeah.
have talked about
Yes, sir.
executable linkageable file. If you remember, what is ELF is executable
No,
and
sir,
linkable file format.
you haven't told that.
आपने लिंकर लोडर के बारे में बताने के लिए कहा था।
I will discuss this, but before that, you should know something else. So let's start with ELF. ELF stand for executable. See, we have PDF. It's a file format. PNG is a file format for images. JPG is a file format for images. Similarly, ELF is a file format for all the things which are going to execute in a machine or link with your anything for a different your source code. These are known as ELF. These are for file format of libraries, object files, these all things stored in your Linux system or in Windows in operating system as a ELF. They are known as ELF files who are going to execute or on anything. So there are various types of ELF. One is executable file which we run on our machine, object file, it's the output after assembler, shared file known as also library, core file I will discuss about in our previous slides, upcoming slides. So let's initiate with executable code. I think all you people know when you just write one code GCC and compile it. For example, if you have a code, see I have one code for with the name of this. If I will check it out file, it's a ELF 64-bit. It's a file format of ELF, and this file is what type? It's executable. You can run it on a machine, and it will ask you some input depending upon how the code is. This type of file is known as executable, which you run on a machine. Uh, so executable is nothing but a output of a linker. After linker, there are some things in your system. When object code is generated, after that executable code is generated. I will cover it after compilation course. This an object code is there, and different things of the compilation are there. So before going to the executable, let's understand the phases of compilation toolchain. Okay, when we write a simple source code with the name of hello.c, what happened? Our source code is hello.c. It go in pre-processing phase. After pre-processing phase, we see a different header files, and these things got included inside it, and the definition are come inside it. What I want to say you is that let's go for a simple hello world program. What we do first, we like include files, right? So let's just consider the example of this code. We have a simple C source code which you are seeing here. Once we have this C source code, what we can see there is that, see, we are talking about compilation phase. So when we run example.c, we get a one file with the name of a.out. Better, I will create one directory, I will show there.
बोला
So we have one a.out file here.
sir sir I have one question.
Yes.
What is this a.out file?
Basically, what happen when you run any C source code, then at that time we get a executable file. You get a file to run on a machine. That file is known as executable code.
Okay, then why compiler give the name as A?
Basically, it's depend upon which operating system you are using. A is the first English alphabet. For that's why the English developer who are working with that file, they give that file name is a.out. They have but they have one option to overwrite it by using -o flag. So I am moving forward. What I want to say is that, see,
Sir, I have another question.
yes,
Can there be two users with same UID in Linux?
no.
What happens if I manually
If you want to know about that class, you can come in Linux classes. Please don't disturb this class. See, this is the this is what you get as out flag. -o flag is used to show what different output file you want to save with when compiler emits it. But here what our aim is, we don't want to go through that out file. We want to see the different other execution step before out file comes inside. There is a flag in a compiler which is known as save temps, which is used to store all the temporary files created by the compiler at one place to show you what other steps are followed by compiler before emitting a executable code. When we write it, what you get these 4 files. Example.c is your source code, a.out is the output file name, and e.i and .o and .s. This .i is known as preprocessing file, which we are discussing here. You have a source code. This source code is preprocessed. After this preprocessing phase, .i file is created. That .file I goes to in compilation phase. In compilation phase, what we get output? We get output as this .s file known as assembling file. After that, we get assembler is there. I have not included there because that is also come inside compilation phase somewhere. What there is only little bit different between these two phases. So that's why most of the people called compilation generates object file, but basically it's the work of the assembler who generate the object file. These are the various phases. If you will try to see this example.c code, what we can see that here we have included one file pseudo-tool, and we have a printf definition in this, and we are returning 0 to the main. If we will only see this file now, first step is what? Pre-processing of the source code. In the preprocessor, emit the output. You will see here. What you see here, different include things. What here is your main. If you search your main, this main is there. Before main, you can see there are different header file inclusion are there. Different header file, all the h2.h source code comes inside and placed here. What all the include file is all about, it get included in your source code along with the main. It is very difficult for you to write it every time. That's why what happened, developer created a pre-processing syntax and semantics for the making your work easy, so that use other APIs. If you will configure it from starting, you can see there are various header file located in this location, which compiler use for pre-processing purpose. So what all the things happen as pre-processing phase, you people can see from my blog here, which I have shared with you with the link. I will come to that location afterward, but you can see in pre-processing phase what all things happen. Your pre-processing, what happened is extension is .i. Yes.
Sir, please make it full screen. It's not visible.
Okay. Is it now visible, Prashant?
Yes, yes.
So you can see that your if you want to see the output, what only preprocessor emits, there is also one flag in the compiler known as -e, which is used to show what only happen during pre-processing side. For example, what happened, you are including one API is known as power function or other function, you will see that it will say that that function is not defined. Mostly this type of error occur at many reasons, but there is also one reason for that error, you are not including the header file for that purpose. Most of the time what happen, your preprocessor files are stored with the extension with .i, and how you do that, you include with hash sample in your source code. Why we use preprocessing, or why we use header file? Any idea, people who are attending class?
To include all library functions.
What that library function is actually is also written by some
सर
people.
उनकी definition वहाँ defined रहती है.
Yes, you
Definitions of various functions are defined in that.
all the things what you include in your source code from your keyword, your variable name, declaration, the way syntax you are giving to them. Not all the syntax semantics, but related to the APIs which you are calling. API I also means for the different integer. For example, you are declaring int. What actually that int is doing, you don't know. You are not worry about that. If there is a C code, C have a keyboard, fixed reserved keyboard. You are declaring this int a, then that int is known as this. All definition comes inside pseudo-tool. So you are using that things. So it omit the use of your source code which you have already declared or done by some other people. So this includes purposes for that purpose. For example, you also use hash defined functionality. If, for example, if I will show you one thing here, I think people are aware about hash define. I am taking a n as 5.
Yes, sir.
And here I am defining int n equal to 5. These two are basically different thing, right? Okay, I will just leave it n1. So these two are very different thing. So what happened if I will write here, they both will give output as 5, right? But the way compiler handles are totally different. Let's see. Or if you want to only see pre-processing file, if you want to only see pre-processing file, then what happen you can do, you can just give one flag as -c. I will open this file t.i. You can see there are various other header files are inclusion in this. So here if you will see that this n1 which I have declared, no, you are not seeing any n1 or n2 here. Here n1 is replaced by see the n1 definition is at what happened, its n1 is also 5 and here your n is also 5, but we have used as hash defined. So it during pre-processing time that variable gets its value, but if you are talking about n is a local variable with the name with its data type integer, but that value n equal to 5 has not gone any here. If you will see, instead of n1 what we are seeing, screen is visible.
Yes, sir.
So you can see that here on this terminal where we have a source code, we have defined hash defined n1 5 and we are using here int n equal to 5, we are printing it. So here what we are using variable name as n1, but instead of n1 what we have its value, right? But for n we have only a variable, not it doesn't got any value. So it means that even your hash defined things, all the things which you include, it gets its value during pre-processing stage, right?
Sir, I have a question.
Yes.
Sir, we have defined n1 as 5,
Yes.
but how we came to know that n1 is an integer type of variable?
N1 is not a int. See here, N1 is neither int. You have not declared. See, is that a question? For that question, you should know how hash defined function handle the thing. For that thing, I have to teach you type def and type different. See, for example, in a compiler, there is the one way you can create your own variable by using type def functionality. When you are using including hash define, then hash define handles everything. How which data type you are using. If you are using character, even it will print a ASCII value of it depending upon that. This hash defined work is to do that. If I will go in that direction, then what is the motto of my class? It will be changed. For your question, you can ask me personally, I will answer there, Akhilesh, okay? Because that's not a motto of current class. We want to see the compilation phase. We don't want to know what hash defined, how hash defined handle the things. Okay?
Okay, sir.
Yeah. So here what happens, see, hash defined n1 5, n1 has changed to what 5, but integer n is remained to n. This is what pre-processing do. For knowing that things, you also know the pre-processing syntax and semantics, how to write preprocessor before compiler. That are different class totally. So it will again exhaust all other people time if who are not interested. I will surely come back to your question after the class. You can ask me personally. So here what happened, you got it what I want to say, right? All the things what we include in our source code, all its definition code during pre-processing time. Basically this file has, we have to include it hash symbol. After that, this file omits this thing. You can see I have mentioned everything. What are the things are important? You can read this for understanding mode, macros and different things. After the pre-processing phase, there is a next phase known as compilation phase. You can read for that purpose. After pre-processing, there is a phase known as compilation, where actually the compiler what it do, it's handle. If you now ask question how compiler handle this, then there is again 6 to 7 step inside compiler. It's again a big topic. So we are covering only the abstract level. We will initiate from tomorrow class basic C. So if you will see this, your source code is getting pre-processed. All hash defined things you have right now. After all the hash defined things you have right now, what will happen? Compiler will take it. When compiler will take it, it will take even like, for example, I am saying to you a word A, B, C, D, E, F. You will, from your mind, you will take it like A, B, C, D, E, F. and then you will try to understand and take a meaning out of it. Similarly, a compiler handle the things the way your human mind works. So in compilation phase, what happened? All the syntax semantics of a variable are checked. What compilation do? It converts your source code to .s file. .s, you know that is assembly file. If I will see, this is our source code, and if I will see what is .s file, what see this is nothing. This is what is all this. This all the assembly code. Actually, your what is your machine doesn't understand human things or high level language. They only understand low level language in 0 and 1. Before the compiler was developed, there was people used to write code in assembly language and some other in depth. So what has compiler did, or the tool chain did, they handle all the things differently, and this assembly file is actual where the things arise. For different architecture, you will see different assembly instruction will be there. If you will see here, your main is taking size sections. These sections are nothing but it consists of many sections. In assembly code, you have a test section, data section, and .bss section, where you can easily see which type of data will store where. Because in interview they also ask these types of question. For example, in text section what is there, in data section what is there, in BSS section what is there. So for that purpose you can refer my blogs which I have written. But what I want to give just overview regarding that. See, this is what it's talking about your compiler which you are using, and proc bits and long bits are two things which I will share you afterwards. After that, there is a, you will see what actually I want to show you. If this is a main and this is your main function which you have written here, this main function doing all this work here which you are doing in here, you have written only 1, 2, 3, 4 lines of code, and assembly instruction is generated a lot. You are using is a printf 2 times. You can see one is a printf definition and one is a putsh definition. So whenever you are emitting any string instead of printf, you call a putsh. But when you are printing any data, integer or variable, it will call as a printf definition will be called. So this is how the assembly handle the things. What all the things are writing here, they will go store here. For example, you have use here int n equal to 5. You can see here at register RBAP, 5 is moving to it at location number -4. This is the way all instruction are being handled. How your compiler, after pre-processing, this is the output given by the after compilation. After compilation, what happened? There is a generation of .o file. You can see here. Are you people understanding what I am saying?
Yes.
See, what is saying? It's a relocatable version of these things. This is what .o file emitted after compilation and assembler together. We mostly, a lot of people take two parts together, compiling and assembling us together, because they are totally interdependent on each other. So most of the people say that compiler emits object file, but if you will go in more detail, compiler only emits two .s file. They don't use object file. Object file is given by the assembler, right? So if you will try to open this, you will not able to open this .o file. It will say it's object code which you can't see, but there is a tool known as objdump or readelf, which is used to disassemble. What you are doing here, you are assembling it, right? In .o file you have assembled everything. Your .s file you have put it together in the 0 and 0 format so that machine can understand. But if you want to do reverse of it, from reverse means you have a 1 binary and you want to extract it meaning and you don't know what to do, then you can use objdump. And if for that purpose you have to also learn assembly to understand how that architecture is handling that thing. So it basically what happened to reverse of assembling. So they are known as disassembling. If you will see the output of the objdump, see, this is your main machine language. So it's a little bit above assembly language. It also has some definition to main plus this OE main plus some above location. And if you will see what your assembly code consists of, This is your assembly code, right? What your things are changed here, you are calling here printf and puts, but it is calling what? Main plus some address, main plus some address, right? This is assembly code. Here you are calling what? Dot plt, dot ex, dot rbx. But here you are calling what? Main plus some location, main plus some location. That some location is handled by the linker, which work is to relocate, which work is to take the object file and assembly code of the things where that location is there and arrange them in such a way that they can generate executable out of it. So assembling, what we know that assembler is .s file which give object with a .o extension. .o extension we know that is not an object code. This object file consists of 0 and 0 and data, and which is used by us for some other purpose. Now what are the last step is linking. Linking means your object code is, you have an object code. Object code means something which is able, which you can run on machine. For example, you have a food. Your food is prepared at your home, but now you want to sell it in market. What you will do? You have to create some other setup. You are creating a food, that's a different way, but when you want to try to sell in a market, that's a different concept. But there also you have to cook a food, but for that purpose you have to make a whole setup to run your food market. So that setup is known as linker, which is used to make your object code in such a way that arrangement so that you can run it on your machine whenever required. Are you understanding what I am saying?
Yes, sir.
Yes. Yes, sir.
You can see here, see, after your object file is generated, you can see that printf and puts definition are gone. No printf, no puts, and nothing else. Only some dump address are there. Only some address location are there. That location will be taken. That location is called as absolute address. Absolute address means a virtual address which your machine create, so that specific linker or some other things to understand it and create a relative address out of it, so that you can run on machine. See, there are two types of address, absolute and relocator. Whenever I will come to the operating system, I will teach you this in much better way. But keep in your mind these things. It will be easy for you to understand the thing. So you can see that, right? Puts definition has gone. It's converted it to main some address, and printf definition has gone. It is converted to main plus some address. Else all the things are same. This CFI start, these things are only gone in from assembly code to object code, right?
Yes, sir.
Now after linking, what happened? You get a a.out file which you are able to run it, right? So now come to the executable file which I was talking about, ELF. ELF is what? A file format. Here all the things which you are trying to run or waiting to create it. This .o file, a.out file, and shared libraries. For example, if I will run a command on a.out, it will show that how much linkers or how much dynamic loaders you are using. I will come to linker and loader when I will teach you first how to compile basic C code. See, you just use GCC for compiling a basic C code. But in industry, when you come to industry, you will see that no one uses GCC and other thing. Yeah, they are indirectly using the GCC, but they don't run like command GCC -o out this thing. They use make and CMake. My motive is not to teach you as purpose to your academics. My motive is to teach you in such a way that your academics plus your industrial life both should get balanced. I will teach you then how to create means you have created these things, right? Object file, and you got a.out file. When you run a.out file, you will see that these things are getting called. These things will, LDD means dynamic loader, which you can refer on Google once. Just keep in mind the name. See, you are calling your libc 06. This libc consists of printf definition, where your printf is located, and these other things are required by your operating system to handle your device to run. So if you check LDD on example.o, what it will say? Not a dynamic executable. It's not a executable, it's just object code. You have created a 0101 binary, but after creating 01 to 01 to binary, what you will do? You have to arrange it in such a way that it should run on a machine. That arrangement is done by whom? Answer. That arrangement is done by the whom? Creating your object code in such a way that it should run on a machine. That yes.
Assembler.
That arrangement is done by whom? If you are facing any noise problem, you can also ping on the chat that that arrangement is done by whom. I can see it there. Assembler is used to create the object code, Akhilesh. Object code is created. Compiler, assembler together create object code. Yeah, linker is the correct answer. Once you have got object code, then object code arrangement in such a way that it can be able to execute on the machine. This arrangement is done by the linker. Yeah, Aditya, you are right. That arrangement is done by the linker, right? Yeah, Ashok, are you understanding the things which I am saying?
Yes, Abhinav.
Yeah. And what about others? All people understanding, who are not understanding, you can ping no so that I can explain in much better way. So now we have seen that executable file, object file, core file and shared file. Executable file means which you can run on machine, simple. Object file means machine code which is ready to be run, but you can't run it. It just consists of all the things which is your source code consists of, but it won't run on machine. Shared file, I will teach in further slides. So you got what executable code is. Is also is the output of linker after it's processed the object code. A machine code file can be immediately executable, that is run as program, or it may require linking with other object file. So what is object code? We have seen that a file with dot extension is known as object code. After compilation emits .s file. .s file is taken by the assembler, and assembler emit .o file, and that .o file is linked with linker, and we get a executable. This is the whole process. It will consist of the external symbol. For example, you have in object code you can see there is a putf. In object code you can see you have seen, right? Okay. Object code is what? It's just a dump file. I have reversed it with obj dump. If you will see it in this main, what you will see, this consists of some o2xe main plus some address location. This is known as external symbol, which is resolved by whom? Linker. And after that you can see this is the complete for process. You have preprocessor file is completed, you got a you have a source code, preprocessor happened, your header file and all the things with all hash statement are processed along with the symbols. Then you get a compiling phase. In compilation phase, this consists of again two phases. One is what? Compiler, and other is assembler. Compiler work is to take the copy of what? .i file and generate a sensible things known as .s file. That .s file will what again happen? It will taken by the assembler, and assembler will emit .o file, and .o file will be given to the linker. Linker are again out of two types, static linker and dynamic linker. So I will again give difference about it, but don't hurry about it. This linker is again created, your executable are created. Now these two things required you to run the file, and this process till linker is known as pre-processing, compilation and linker, together known as build process, and linker and loader known as running the process. Once your loader is there, you can use CPU. And for example, now I have a binary known as a.out, right? What we want to do now? We want to run it. What we will do? You will just simply type /a.out. You will get that this is the output. But how this operating system is able to emit this? After you are executing it, it required three things. If any of these three files will be not there, it won't run. I will show you in future while running the C classes by doing some more experiment. So that things which takes your executable to the operating system, and your operating system can show you some output, is known as loader. That's the basic difference between linker and loader. Linker is what? You have object code. It makes your object code in such a way that it is ready to run, and the things or the tool which is used to run it is known as loader. Make sense?
Yes, sir.
Yeah, can you give some examples for loader?
Yeah, these are the what are here you can see .so.
Like IDs we can say, or
If you want to take loader example, for example, all the things, operating system is an example of you can say operating system utility are example of loader.
okay.
Yeah, and all the things which are running, which are a mix your is known as a loader.
Okay. Okay.
So, an example of linker.
See, if you will ask me example of pre-processing, all the things which is make your code to run is known as what? Loader, right? And if you talk about linker example, then this one all the this was shared libraries. These are known as .so file, .1 file is known as a shared library, right? Hello?
Yes.
Yes, sir. It's right. Yes.
This is known as shared files, right?
Yes, sir.
So loader is nothing. Loader, you can say that is the program of the operating system which loads the executable from disk into the RAM. You have things in your disk, right? Means a dot out is where stored in your secondary device. What happened? You just run a dot slash out. Your things go to RAM, and you run it. This is the thing. The utility which is used to do for operating system is known as loader. Okay.
Yes.
Yes, sir.
We
Yes.
can do. This is showing all the things required things of my system. Or you can just use one utility known as strace.
Sir, it means that linker and loader both work together.
Linker and loader don't work together, but they are interdependent on each other. For example, you have two hardware. One is of x86 and one is of ARM. So once you are linking with the ARM architecture and you will run on x86, it won't run, because that's where actually backend happens. Okay. If you want to see the linkers used by your loader used by your source code, you can simply use a system call known as strace. For example, if I want to know strace ls, if I will do, it will show you all the things what ls is using. Similarly, if I will write my code eg.c strace see, it will show you all the things what is using. See, it is showing that this is he is using as these loaders. You can see different output of what all the system calls they are doing to run it. System calls means to interact with operating system from user mode to kernel mode, which I will teach you in after future classes. You can see here, right? All the things you can explore it by the way how the things are loader used by the thing.
Okay.
Yeah.
And Abhinav, I have one doubt.
Hmm.
I had seen some CPP files with C.
Hmm.
Is that correct? Like we can link with the CPP files with C. Is it possible? And how
CPP.
it will handle? Like CPP files will also support some C files, right? Because of compiler supports. Like
See, basically, if you will see, you won't get a source code for G++. We'll only get source code for GCC. Both are wrapper call for each other. So depending upon how the compiler utility they have written, it handles in the similar way. You can't, yeah, similar way. What happened? What I will do instead of For example, you will see that there is a one variable u int 16 most of the time in in embedded system, right?
Yes, yes.
What they do nothing, but they write just
Yeah,
type
just
def,
def or-
type def. Similarly, the way they have handled it. For example, if you want to create your own variable, or if you want to use own upper class, then you can use that. But compiler concept doesn't change here, but the way you are using it is different. That's it.
Okay, if they are using and they are running CPP and C files both at a time, then they design their own file. Right?
Yeah, accordingly to that. But if you will see, okay, just see what happened. I will just show you one demo, right?
Okay.
See what is taking undefined reference to main because I have not created main function, right?
Yeah.
So if I will just what happen if I will int just let create this function main, right, and do nothing. So your GCC is running, right? GCC is running
Yes. Correct.
simply. But if what happen if I will use here, just type here printf.
Now it will give error because we
No,
didn't-
it will again run.
So does .cpp means C++?
See, it's saying that printf is not declared. But what happened? Just
Yes, yes.
move it dot cpp file. At least I will answer your question in 2 minutes. Just wait. I am running it.
Okay.
No, actually, okay, I have moved it. Oh, no problem. We can run it like a dot c. See what happened? It's only given warning that printf is implicit declaration. But when you are using G++, it's again say that printf was not declared. So what happened basically the G when you use G++, you can also see, wait, I will write to see what happened. You have one file with the name of .c extension, right? This is your hello world code, int main printf hello world. What happened? By default, when you run GCC, it will include has include inside it. You can see by just see minus GCC minus e minus o a dot I vi a dot I. You can see what by default if you have hello main, it's including some file std preferred which is required for running your
GCC
your what you running what running your
for
printf definition. You can say printf definition. By default std.s is included in G++. When we run when we run G++ here, it's again taking this definition also. It's also including all the thing. But if you will see during compilation phase when we will create, I don't know, are you people of okay, just no problem.
yeah we can.
Executable is not generating, that's why it's throwing error. You will see that a.ii this file is generated. So just examine our vi a.s file. Oh, a.s file is now generated. Why, man?
It get an error, right? It will not create. The compiler will fail, right?
Yeah, compiler will fail at I think after pre-processing it will fail. So that's why it's not generating. But
it's not generating. Yes.
yeah. So why it's not generating? Because okay, that's my experience. I'm saying when you call G++ now, or you can see by this way. Okay, wait, I will show you other way. This is a verbose operation where our compiler is moving. It will show you that all the things what compiler is including. Just we are copying it at one location. Okay, just what happened? Let's save this output of with the name of G+. So we can see that it's not saved. Okay, not we can save it by this. Not much. It started from here, right?
Yeah.
Now let's run GCC here, right? Again, what happened? We'll save it. Now let's check the difference between them.
Okay. Primitive.
When you see here, see, this is your GCC one. It's saying, but if you will see your G++, by default you will see lots of differences are there. There is one specs file inside your compiler which decide when you are using GCC, when you are using G++, how to handle the compiler called known as configurations.
Okay.
That file is different. That's why you see different output.
Yeah.
See, and nothing else difference. Much more you can see. This you can see lot of difference. Okay. Now, Chris, what's your question?
Oh,
Sir, that extension that you were using .cpp was a program of C++.
See, extends. If I will write, see. Okay, I will show you by example. Just time int. Hello.
Yes, sir.
See, what happened? I am running with the extension as a.cpp. But when you are running it, it's running, and you can also see the output, right? But when if I will include, what it's saying, undefined reference to this. Basically, it's not .cpp, not .c. In operating system doesn't understand your .c, whether it's a .c or .cpp file. Operating system always understand what a 0101 object file when it's linked with the linker. So basically, what happened? At what name you are saving? Let's say I am saving with name of A. Okay. See, it's what is saying, it's not recognizing. But if you write it here a.c, why it's not recognizing? Because your GCC code, inside GCC code they have mentioned a parsing for .c.cpp file. If you will not use CPP, C++ API, if you will not use this IO stream, it will work, because that IO stream is a C++ file. Means when you call this IO stream, it should go how GCC should handle, not GCC, G++ should handle it. That's why all the any extension which you use here, whether it's C or CPP, it doesn't matter. When you include it, what happens? G++ is written in such a way that it will handle all C++ file, and GCC is written in such a way that it will handle all C+ file. But if you will write C file in .cpp file, GCC will able to handle it, which I have shown you, right?
Sir, it means that we can convert one language to another language using compiler, GCC compiler.
No. It's not about converting the, see, the way your compiler handle things, see, you see compiler as a black box. So you are giving it a source code and giving you output. But inside compiler, if you try to understand the compiler in much more detail, compiler understand your thing how by this extension. Extension is required for whom? Compiler. When you will write .cpp file, it will go for G++. It should go for G++, but not like that. When you will give here GCC a.cpp, it will run without any error if I will not include C++ utility. If I am using C language inside inside our source code, and you will save with .cpp extension, it will run. But if you will include C++ concept, it won't run. That's it.
Okay, sir.
Yeah. Basically, what happened when you, for your purpose only, why we write in any extension, so that we can understand it's a C file. It's a okay. If I will write file a.cpp, it will say C source code, but your save extension is a.cpp. If just you have, just wait a minute. If you will include this remove, It will again, even G++ will show error. You will see that printf definition is not there, but it won't. It has not shown error. Why? Because C and C++ are mostly related to each other. Some things are supported, some are not supported. So it's better to use all C++ together and CPP together. Don't mix them together. See, you are getting output. You have included here. Just include this file also. You will again get alert. But if you will use GCC here, it won't run, because you are using C++ concept here, no? Are you understanding at least what I am saying?
Yes, sir.
Okay. Any more question?
One more thing, Abhinav.
Yeah.
We use hash include with the angular brackets and double quotations, right? Like
Yeah.
that. How it will work when pre-processing stage to make
See, for example, we have. Okay, you want to see, for example, there is a way we can create our header file in C++. Just remove, it's all mess up. Let's remove everything from here, right? See, now everything is removed. Now I will show you, for example, you want to create our header file, right? That's the question.
Yeah. No, not like that. After creating header files, we include the header files with the double quotations and sometimes like hash include with the angular brackets, right?
Yeah.
So how they work in compilation stage?
Okay, look, I will show you. For example, I want to create two function. We want to create my header file, right? My head.h, right?
Yeah.
We have included. Its work is to add to number.
Yeah.
What happened?
Give insert.
No, actually, it's hanging. System was hanging.
Yeah, fine.
Void add int a, int b. Okay, instead of void, let's take int return type.
No, here header file, right? You just declare it and create another .c file.
No, but if to understand it, you can know it now how you are using
Okay.
it. For that was
Fine.
I am writing that. Okay. That you are returning just a plus b.
Okay.
From that function. So what my header name is? My head.h. So what happened initially? I will let me create h.c file. Right. What we want to create h.c. What we will do? We will what was header name? I forgot.
My head.c .h. We just copied.
So let's creating. So has. We will include a stereo definition.
Yeah.
And we want to use our what function?
My head.h.
Yeah. Okay, just write int man. And let's create a variable with name int a equal to what was the function?
Add. Just
Add it taking two parameters, right? Add 4, 5. Okay. Makes sense?
print it once.
Yeah, that I will do.
Okay.
How bit? Okay.
Yeah.
Okay.
Okay.
So it's working, right?
Yes.
So let me first let me teach the people who don't know how to create their header file. For example, you can also create your header file in C++. Just you have to in order to show that it's your header file, you have to just use this double quotes to know that it's your header file. That it's created by you, not it's when you give you single colon, it will search in the directory. It will start searching from where C files are getting stored. But when you will write my head.h in double quotes, it will start searching from the location where you have put the things. Okay. Hello.
Sir,
Yeah.
sir,
Yes.
sir, how can we create our own library?
Yeah, I will teach you, but that's for creating your library. You should know little bit C, right? You can't directly jump.
And sir, one more
I will
question.
teach you everything. If you want to learn anything, then please ask me question after this. Just 2 minutes. Means you can ask. Just let me explain what I want to explain. So, see, I am using -e file. Oh, it won't say output file. So better -e -o h.i. Okay. So if you will see that you are calling mint a, but in C, in my head, it's taken location from my head. It defined your code there, nothing else. It will define your code.
Okay.
You can see that all the thing which you will see now, it will define your code there. This is what actual code you should write to run a C source code if preprocessor was not there. Different function, see, different way they call, another way you can see from top to down, top to down, top to down. Then if you'll see main, it will do nothing. It will define your things there, and you can use. If you will use hash define there, it will just return here 9. Okay, just okay. Ashok, have you any more doubt?
Yeah. Yeah. Nothing. I understand.
Okay. Akhilesh, what you are asking, right? Tell me now.
Sir, is C++ is totally supportable to GCC?
Not totally. It depends upon how the compiler handles things. As the question you asked, I will answer in one way. It's not totally supported, but if you are not using any C++ concept, till that time it will support. So if you will see that at compiler abstract level, it consists of 3 things: front end, back intermediate, and back end. Front end means your pre-processing phase, and compilation tilde auto. What you get tilde auto, it's known as front end. Here you don't have to deal with hardware, only means software handle the things. This phase is also known as analyzing phase. Source goes to IR. IR means intermediate form between your front end and back end. There is the one object code generation, and there is the one more phase known as IR, and intermediate bit code object and back end executable. Back end means where you run the code. When your linker and loader come in side picture, this is known as your back end. Okay, understood?
Yes, sir.
So,
Yes, sir.
and now you know that what is object code? Sequence of statement in binary that is generated by after compilation, known as front end. And what is executable code? Executable code instruction which are directly executed by the CPU can run. Oh, I should change it here. Cannot see. Cannot run on machine code. Can run on machine code. And we have seen these pre-processing phases, right? You people have understood these things. So I will just share this PPT, and people can visit my
And one
website.
more thing was there, the name core.
Okay, core file. Yeah, okay, core file. What is core file? If you want to know, core file is nothing but there is the one file. Okay, actually that's not that much important. It was a part of executable. That's why I shown you. If you will see the man, for example, if you want to know, if you don't understand anything, in Linux there is a utility known as man command. If it's related to the Linux OS, it will, if you will try just man elf, it will show what is elf is. If you will write here man gcc, it will show you what all gcc is. You can use this manual command for understanding it much better.
Sir, what is the default pager that the main command uses?
Default
Pager.
pager means I didn't get.
Pager means the editor or text viewer that it uses, more or less Vim.
Vim. Default it's Vim.
Okay. If I want to change that?
There is a way, but I don't think I will ping you personally. Just message me because I don't think it's related to class.
Okay, sir.
That's a Linux utility. Now, when I will initiate Linux classes, then I will show you all the Linux tool which you can use. Even man, there is some better tools than man you can use there. But no, just don't trust there.
Okay, sir.
Yeah, our agenda is to know what core file is. You people have come to some time in your life error such as segmentation fault, right?
Yes, sir. It comes like code dumped.
Yeah,
Like this.
like how you know what is that dumped? Why do you get segmentation fault? Any idea?
Sir, maybe we are searching for the memory which is not actually located at that area.
When you run anything, you should take permission from whom? Operating system. Or how you give permission by your source, how you decide it by your source code. If your source code that permission is not there and you want to access some location which is not assigned by you by the OS, then you will get a segmentation fault. That's the basic definition of segmentation fault, why you will get, right? What that core file do, why you get core dump? Because whenever operating system assign you memory location, the files which is used to keep the snapshot of it, means data about it, is known as core file. Okay, have you got it? Core file means nothing but memory assigned by you, the snap or record taken by the operating system to assign you memory is known as a core file. Have you got it?
You mean file at RAM?
Yeah, you can say memory image of a running process is known as core file. For example, if I will show you ls minus la slash, oh, what happened? See, these are the things here temporarily or somewhere used by the OS to show you something. These all temporary files are known as core files, or you can say the things which are required to give you access.
Okay.
It's a memory image of process at a point in which the time when it was terminated. You can say also this thing. And yeah. If you want to see any, actually I don't have that thing installed, neither I will show you how to see. Okay, I will let you know how to see core file in next tutorial. Because for that once utility should be there in OS, or not a way, there is other way, but actually that will be show you better way, so that you can understand much better way. So I have not discussed you with regarding a shared file. This, what is this? Shared object. I have discussed with you that there is a library, right? Library is nothing but a source code written by you in a such a way that, see, you have written this code, right? Here no main, you have just created int a, int add and written 0, no header file inclusion, nothing else, only just functionality of code you have written. So it's a simple function, but if you want to write multiple big functionality, then you will create? You will create a bunch of code together. That togetherness is known as library. Functionality, which the code which only consists of functionality, and you will share what this object code is shared by you to some other people to link it dynamically and statically. This is known as library.
So that means that earlier you were using has include, and you have written something in double quotes that was not library.
That was a header file. For example, if I don't have a header file, I can't include everything in header file. The reason is that when you include everything in header file, your size of the binary increases, your size of the source code increases. This led to create your binary size much more. To handle that, library comes. The functionality which you require, just put in one place and link it during linking phase. You don't require, see, you know that you have functionality comes inside you, right? You have functionality of the things with you. And once your object code is created, you know that we require a linker to link it, right? You will write everything, but for example, if you want to use pow function, there may be chances that pow function you have, for example, if I will write here, Okay. If I will run it, I think it will show error. See, what is saying that warning is saying that you should include math.h, right? But if I want to just use power function, and if I will include math.h, then all the source code of the math.h will come inside our source code. It will make our source code very big, right? Hello, are you agree with me?
Yes, sir.
Yeah, it will make our source code very big. But if you will see, you run on hardware. Right now, you have a hardware of operating system at very big. You have a very good operating system. It maybe have 8 GB RAM. But when you all work in industry, you don't have that. You can say liability to work on 8 GB and 10 GB more than RAM. You mostly work on processor with limited memory. When you work on limited memory, you can't include header files and all these things, because even it will you have to optimize your code in such a way that it should take less space. So library is using that case. I will teach you how to create your own library, but take in mind that if you want to run anything, for here libc is a library which contain a printf definition, right? Similarly, there will be library which consists of your power function definition. Library means nothing but a bunch of C code which consists of only functionality. You just remember that, which you can share to everyone. And libc, okay, have you got it? Hello?
Yes, sir.
Or you can
Yes,
also
sir.
say a library is a C collection of header file, which you can include it during runtime or anywhere. And that see, every time you know that if some functionality is built, you don't have to run it every time, right? For example, you have seen that your one part of source code is correct, another part of source code is wrong, and you are running a multiple file. Then you want to only run that file which is throwing error, right? You will there are huge codes are there, then it will again take more time to compile. So library are consist of object files. So if they are already correct, you don't have to run it again and again. This is also an example benefit of using library. And libraries are also known as shared object because they can be shared among different users of different places. Okay.
Yes, sir.
For example, libc is a standard library. It consists of all the headers and objects required by C source code to run. I will teach you these things in upcoming class, because for creating library you should know some basic things of C. Once we will initiate from tomorrow, I think I will initiate my class on basic of the C. We will cover starting from starting to the till you see tree graph and everything. After that, I will also teach you operating system. Your people operating system is going on, right? Hello?
No, sir.
Okay, but I think in
No,
next
sir, not yet.